Hi, my name is Nick Borson, and about a week ago I published a video called Database Access in PowerShell, in which I demonstrated how to query a Microsoft Access database from a PowerShell script. So this video is going to build on that one, and I'll include a link to that earlier video in the description. But in this video, instead of using PowerShell, we're going to use C#, and we're going to use the exact same queries, but instead of having a script that you run from a terminal and have a terminal-based kind of experience, this is going to be a GUI application written in C#. And this application uses the WinUI 3 framework, which is a user interface framework for Windows. That's part of the Windows App SDK. So key concepts that we're going to cover in this video are XAML, which is XAML, pronounced XAML, stands for Extensible Application Markup Language. And this is a markup language that describes the layout of your controls in your user interface. It's a little bit like HTML for the web describes the layout of content in a HTML document, which can be really like an application. But this is a different framework that's used for many Windows applications, including a lot of the Windows shell. Along with XAML, the key concept in this video is data binding, which is a technique for associating a data source, which can be from a database or just any collection of objects, associating that data source with controls in your user interface, and the content then of those controls are automatically populated with the data that you specify. Data binding is used with XAML. It's also used with other frameworks. It's used with HTML. A lot of HTML tables and stuff for web applications can be populated using data binding. So it's a common technique when building user interfaces. So to review the previous video, this is the output of one of the scripts that I demonstrated in that video. And it shows the results of two nested queries. So first we have a query that returns all of the orders in the database. So the database has a table of orders representing customer orders. And for each of those orders, we get back the customer, and we get back an order ID, and then the customer, and also the date on which the order is shipped. And we filter that list. The database has a bunch of orders, but we filter that list to only include orders that are in a certain state, the shipped state. Then for each of those orders, we have another query that returns the order details, which is the individual line items. And in the script, we total that up so that we have the total cost of that order by adding up the individual line items. So for example, the first order, we have the customer is a Datum Corporation. We have the ship date for that order. And then this order only has one line item. So the product, we have a product name, we have the unit, the count, or the number of units. We have the unit cost, and then the product of those is the total cost for that line item. And then we have a summary, and in summary we report the total. And then the second order has three line items, or three order detail items, and likewise, we have the product name, the count, the unit cost, and then the total for each of those. Okay, so that's the PowerShell script. And in this video, I'm not going to go back and repeat myself and explain the structure of the database and exactly how those queries are built, because that's all explained in that previous video. So if you want that information, I would suggest you go back and watch that previous video, which again is linked in the description. But in this video, I'm going to explain how to build a user interface that, instead of giving this kind of textual representation, shows a GUI representation. So here's the app we're going to build. I'm just going to bring it up here. So here we have a two-pane view, where the left pane is the list of orders, and then the right pane gives you the details for the selected order. So each time we select an order, then the right side pane changes to reflect, to show the details for whichever order is selected. So it's the same information that we have in the script, but it's presented in a little bit more user-friendly and graphical way. I did not include, just for simplicity, I did not include a column headers or a summary row with the totals. So I'll just leave that as an exercise for the reader, if you will. All right, so like I said, this application that we're going to build is constructed using XAML, and it's based on this WinUI 3 framework, which is part of the Windows App SDK. So the first thing I'm going to do is sort of walk you through just creating the sort of the basic starting point for your project. Before we can do that, there are some some prerequisites, some things we need to have installed. So I'm going to walk you through that first. So first of all, we're going to be using Visual Studio 2022, which is Visual Studio is Microsoft's integrated development environment for Windows. So it's in a lot of the PowerShell demos, we've used Visual Studio Code, which is kind of a very stripped down, lightweight kind of text editor, which does support a lot of development features and stuff. But the Visual Studio, the full Visual Studio integrates a lot more features and has a lot of functionality that is useful for creating complex projects and stuff. So anyway, there is a free version of Visual Studio which you can install from the web called Visual Studio Community Edition. And then there are other versions of Visual Studio that have some enterprise features and so on. But the free version will do everything you need for this. Visual Studio, because it supports a lot of different kinds of applications, a lot of different types of projects, and many different languages and so on, the setup for it is modular, so you can choose what functionality you want to actually install. So for this purpose, we're going to build a .NET desktop application. So to choose what we need to install, we start by, in the Workloads tab in the installer, making sure that the .NET desktop development workload is checked. And then on the right-hand side, you see there's a pane that says Installation Details, and these are grouped by workload. So under the .NET desktop development workload in that pane, there are a bunch of optional features. And one of those that we want to make sure is checked is Windows App SDK C# templates. So like I said, WinUI 3 is part of Windows App SDK, which is a framework for Windows development that has a lot of functionality that used to be built into Windows, but it has been lifted out of Windows so that you can actually you can actually have like the latest and greatest features even if you're running on an older version of Windows. So that's what Windows App SDK is. And WinUI 3 is kind of the XAML framework for building user interfaces that's part of Windows App SDK. Okay, so once those things are both checked, then Visual Studio Installer will make sure that those components you need are present. And then we can actually run Visual Studio and create our project. So you choose New Project from the project menu, I guess it is, and then you get this this wizard that walks you through the project creation. And when you create a project, you create it from a template. So if you type WinUI 3 in the search box, it will show you the project templates with that in its name. And the one we want is the one I've circled here, blank app packaged, WinUI 3 in desktop. So you select that and click next. And then you have an opportunity to type the name of your project and the location. It will create a subdirectory with the same name as your project under that location. And then when we click create, it will create a kind of starting point for your project. So this is a screenshot of the initial project that the template creates for you. And it includes on the left-hand side in the Solution Explorer, this shows kind of all the elements that make up your project. And among those elements, there is this main window.xaml file, which is the XAML file, which is an XML-based markup that shows what controls and other classes and so on make up your user interface. So you can have multiple windows, but in the starting project, you just have one window. And the top level XML element is called window because we start with a window. And the x:class attribute of that window is actually the name of the C# or the .NET class that this XAML is going to construct for you. So when this XAML gets built, it actually generates code just like compiling C# code generates code. So it's actually going to generate a class called main window in the query demo namespace, and that class will have code that's constructed from this XAML markup. In this XAML markup, as part of the window, then we have the content of that window is a stack panel control, and that stack panel control in turn contains a button control. And the button has a name, which actually then becomes a field of your class. So my button then is a field of your class, or a property, I guess. It has the click attribute here is referring to an event that the button class has. So when you click a button, it fires a click event. And in this case, when you do that, it will, this markup is specifying that when that click event fires, it will invoke an event handler called myButton_click. That is a method of your class with that name. And then click me in between the button start and end tags is actually the content of the button. So if we run this program in the debugger, this is what we see. We see a click me button centered in the window. It's centered, by the way, because if we look back at our markup, the stack panel has a horizontal alignment center and a vertical alignment center. So the button is centered, and when you click the button, then the content of the button changes to the word clicked. And the reason that that last bit happens is, again, because of this event handler we have. When the click event fires, it invokes myButtonClick, and myButtonClick is defined in this code behind file. So it's a C# file with the same name as the XAML file, but with the .cs added at the end. So this C# file defines, so essentially we have the main window class is defined in two places. It's defined partly in the XAML markup, and it's defined partly in this C# file. And because of that, that is why we see on line 24, where the class is declared, we have the word partial, because that is telling the C# compiler that some functionality of this class is actually built somewhere else. You know, it lives somewhere else. It's not all inside of this class definition in this source file. So there's the XAML produces part of the class definition, and then this C# file produces the other part of the class definition. Specifically, when the class is constructed, you see that there's this the constructor, the main window constructor, invokes a method called initializeComponent. Well, that method is actually generated from the XAML markup. But anyway, when we click that button, then our event handler, myButton_click, is invoked, and that is where we set the button's content to the word clicked. And by the way, on line 33 there, myButton, the reason myButton is understood and makes sense is because of that xName attribute in the XAML. See on line 12, x:"name equals myButton. That means the button actually has is a field of our class, field or property, I'm not sure which, but anyway, you can access that button control using that name in your code. Okay, so that's a very quick introduction to the template the results of running our template and creating kind of the placeholder project. So far, we haven't actually written anything ourselves. We haven't done any of the database stuff that I'm going to show you next. But I just wanted to give you a quick introduction there so you can actually get started creating your own project. Okay, so let's start actually building our application. Starting with the code that the template created, I've deleted the stack panel control that the template created, and I've replaced it with a two-pane view control. So I chose this control because it seems like a good fit for the kind of user interface that we're trying to build. If I go to the documentation for this control, it says that it is a layout control that helps you manage the display of apps that have two distinct areas of content, like a list/detail view. That's exactly what we have here. We have a list of orders, and then when you select an order, we show the details for that order. So we've gone with a two-pane control. two-pane view. The two-pane view control has two properties called pane 1 and pane 2. Pane 1 being the list and pane 2 being the details in this case. So the properties in XAML can be specified in two ways. A simple property can just be specified as an attribute, but for complex properties, like in this case where we're creating a whole control underneath it, we instead use this kind of syntax where we have a child element with the same name as the class, as the class it belongs to, and then dot property name. So this is setting the pane 1 property of the two-pane view control to whatever the content of this element is. So if we expand this out, well, first of all, for pane 2, this one's very simple because so far I'm just putting a placeholder text block into pane 2. So pane 2 is just going to be the word text, or it's just going to be the word pane 2 displayed as a text block. We'll get to pane 2 later, but for now we're just going to build the order list. So for the order list, here, let me collapse this down just to show, let's see. Okay. So for the order list, we're going to use the list view control. The list view control is just a control that shows a list of items. And the attributes of the control we specified here are first of all, the x:\name attribute is just the property name or field name by which we refer to this list in code. And then the item source refers to a collection of objects that we are going to use to populate the list. So this is an example of data binding. So the list view control is a type of items controls. There are a few other items controls. These are controls that have an item source property that you can then bind to, that you can bind to a collection, and each element of that collection becomes an item in the control, in this case a list item. So the value of this, the attribute value here, is enclosed in curly braces. That's, in XAML terms, that's called a markup extension. And the xbind markup extension is used for data binding. There are actually two kinds of data binding. There's the old style, which is called binding, which is just uses the word binding, and then the new style, which uses x:bind. I say old and new, but they're both still used. The word binding is a form of data binding that is interpreted at runtime, whereas the x:bind type of binding is compiled into code at build time. And I prefer the former is, I think, a little bit more flexible in some ways, but I prefer the compiled bindings because they're more efficient. They generate more efficient control at runtime, and also because you discover at build time, you get errors at build time if you do something wrong, and so you can actually fix your mistakes a little bit more easily. Anyway, so for the xbind markup extension here is just saying that the items source for this list view control is the orders property of this class. Again, we're building we're building a class called window that is partially defined in this, we're building a class called main window that is partially defined in this XAML file and partly defined in our code behind file, which is here. And in our code behind file, I've defined a property called orders that returns a list of shipped order. Okay, so that's the return type of the property. This is the name of the property. And then what the property does is it returns, it invokes a method to get a list of shipped orders and returns that. So when you get the property, it returns the results of this method call. Okay, but going back to the XAML, when this control is initialized, it will actually get the orders property, which will give it a list of shipped order objects. So shipped order is a class that I will get to later that's defined in another file. And then for each of those shipped order objects, it will create an instance of the item template, which I will show you next. So it will add a list item, And since we've defined an item temp, by default, the list item would just be whatever that object is converted to a string. But you can control the exact appearance of your list items by using an item template. So here we've created we have a child element called list view.item template. So again, we're setting the item template property of the list view control to the contents of this element. And what's going to happen then with the item template is that for each object in the list, for each object in our orders collection, the item template is going to be instantiated with that object as the data that is, with the properties of that data used to instantiate the template, the properties of that object used to instantiate the template. Okay, so let's go ahead and look at this. So the value that we associate with an item template property has to be a data template. So data template is an object that can be instantiated to produce a control that in which so a data template defines kind of a template, like a stencil kind of, for these are a whole set of controls, but they're not real controls until we actually instantiate the template. And there are placeholders for controls that will be created for each item in the list. So for each of our list items, we are going to create if we look again at the appearance of this app, I'll run that here. I'm using Control F5 to run the application. We see that for each item, we have this gray box, and there is white space around the box, so there's space between the boxes. And then there's a little bit of space within the box that's called padding between the box and its and the text and the content of the box. And then inside the box we have a bunch of different strings that are laid out in a certain way using a grid. So the gray box is defined by the border element, so that's the top level element under our data template. It has a background brush, which is defined using this static resource markup extension on line 13. So static resource, again, is enclosed in curly quotation or curly braces. So that is again a markup extension. The static resource, which means it's essentially, it's evaluated in some way. It's not just a literal string. So the static resource means that this is referring to an object that is defined somewhere else in the program. Or in this case, it's an object that's defined automatically for us. It's part of the framework. So this is using the button border theme brush. I just picked that because it had a color that I thought seemed reasonable for this. You could also just hard code the color. In general, using theming is a good way of ensuring that if the user chooses a high contrast theme or a dark theme or something like that, that you will get colors that actually contrast properly and so on. Anyway, so we've picked a background brush. We specified 10 pixels of padding inside the border. So that's between the edge of the border and the content, the grid. And then 10 pixels of margin around the border. So outside the shaded area we have some white space, and that is the space between those elements. Okay, so that is our border control. Then the actual content that we are showing is laid out using a grid. So grid is a control that allows us to lay out content in sort of a tabular form. So we define rows and columns, and then the grid can contain any number of user interface elements, and each of those elements can specify what row and column it goes. It's what row and column it is positioned in the grid. So for this grid, we have the grid.row definitions as setting the row definitions property of the grid, which is a collection of row definition objects. And pardon me, we have 3 rows. Each of them has a height which is set to auto, and that just means that the row height just automatically is set to the whatever is contained inside that row. The row is just tall enough to fit its contents. And we have likewise have three columns. The left column is just big enough to fit its contents, so its width is auto. The middle column is, we don't actually put anything in that column, but it has a width of 10, and we're just using that for white space. And the right column has a width of star, which means that the right column fills the rest of the space. So whatever the width of the grid is that is not taken up by the left and middle columns will be allocated to the rightmost column. Okay, so then we have a bunch of text blocks. So these are all these strings that you see inside the box, inside the gray shaded area, inside the grid. So the first two text blocks are for the first row. You see that the grid.row equals 0 for those. And the left-hand text block in column 0 is simply the string order ID. So text equals order ID, just a literal string. And this text block has a style. That style determines things like the font and the font size and so on. It can specify any number of properties. And I've just used again, using the static resource markup extension, I've just referenced a predefined style that's part of the framework, so I didn't have to create a style myself. But you can define your own styles if you want to have more control over how things look. And again, the text is just the literal string. Now on the right-hand side of that first row, so grid.row equals 0 and grid.column equals 2. So these are zero-based indices into the columns and rows. We have another text block with the same style. So caption text block style, which is kind of small text. And in this case, the text is no longer a literal string. The text is another binding expression. So we're using the xbind markup extension inside curly braces. And the value the property that we're getting is called order ID. Now the order ID in this case is not the order ID of the window, of the main window. It's the order ID of the shipped order object that we're instantiating this template for. Okay, remember we're going to instantiate this template once for each object in the list. All of those objects are expected to have type shipped order. And the local colon prefix, by the way, means that this is referring to the .NET namespace, which is right here. So it's in the query demo namespace. The class name is shipped order. And we expect then that shipped order class has an order ID property, and that property value is going to be the text of this text block. So back to our actual running application, we see that order ID is 28 in this case. So that object has an order ID of 28. Then the second row is the text block on line 34. So we're on row 1 now. This text block has a column span of 3. So this single text block spans all 3 columns. And again, we give it a different style. We give it a body strong text block style. So it's a little bit bigger and a little bit bolder. And then the text in this case is again another xbind markup extension, another binding expression. And this is getting the customer name property of that object that we're instantiating the template for. And then likewise for the bottom row, we have the word shipped on the left, and we have the shipped date property on the right. Okay, so we close out the grid using the end tag, close out the border with an end tag, close out the data template, close out the list view item template element, and close out our list view. So that's our left-hand pane, is this list view, which is bound to a collection called orders. And each order then is displayed, or each of those objects, which is of type shipped order, is then used to instantiate this data template to produce what we see here in our user interface. We've seen a little bit about how the data binding is used in the XAML markup. Before I go into looking at more of the code, let me just talk about how data binding fits into a software design pattern called Model View Controller, or MVC. And this is just a Wikipedia page that talks about model view controller. And this is a principle of user interface software design that is widely used, not just in WinUI, not just in XAML, but on the web, and all kinds of different frameworks use the similar approach. The idea is to avoid the kind of complex web of interdependencies that can occur if you develop user interfaces without any kind of design principle to organize your work. So what can happen if you don't, if what can happen if you aren't using something like model view controller is that you might have your program has a bunch of state, right? The state is both the content that you're displaying and whatever other state you might have, and then you have elements of your user interface that are controls or other things. Those controls might manipulate that state. Well, when you manipulate that state, then other controls need to be updated to reflect those changes so that you still have a consistent behavior. If you don't use something like model view controller, then you could end up in a situation where every control needs to be aware of every other control, because one control makes some sort of change to the program state. Well, then it needs to go and update other controls to reflect that fact. So as your user interface gets more complex, that web of interdependencies kind of grows exponentially as with the size of your program. So model view controller is a way of bringing some order to that. So you have a general approach that, as long as you follow that approach, you don't have this kind of combinatorial explosion of interdependencies between things. So the basic idea is that the data, which is kind of your program state, could be the contents of a document, could be the contents of a database, or what have you. That data is called the model. And then that data is defined separately from the code that presents what that model looks like to the user. That's the view. So on one hand you have the view, on the other hand you have the model. The model doesn't really even know anything about the view. However, the model does have some sort of interface that allows the view to ask the model about itself. The things in the view can then refer to pieces of the model. And furthermore, the model has some sort of mechanism to notify any other code that is interested of changes to the model. So the view then has to be aware of the model. So pieces of the view are showing pieces of the model to the user, and when the model changes, the view just simply listens to events, subscribes to events from the model, and updates itself. Then if you have things that make changes to the model, that goes through another component called the controller. The controller manipulates the model. Changes to the model then result in some sort of events being fired, which the view just subscribes to, so the view will update itself. So the code that changes the model doesn't have to then be aware of the view. It doesn't have to go through and say, oh, anytime I change this piece of the model, I have to go and update these other controls. All it does is changes the model. And the controls that care about those changes will listen to the appropriate events and update themselves. So there's a certain kind of, having this kind of discipline allows the program to not grow too much in complexity. Data binding fits beautifully into this approach because it is a way of associating a control, which is part of the view, with some sort of data that backs the control, which is the model. So data binding is essentially a particular technique that fits into this software design pattern, this general way of thinking about code called model view controller. All right, let's go back to our program. So we've seen how we had a list view control, which had as its item source, this item source was a binding expression that referred to the orders property. So here's where we define the orders property. So the orders property is called orders. It returns a list of shipped order objects. And in this case, the property is a read-only property, so it has a getter And we're using this syntax, which is the lambda syntax, to implement the getter, because it's a very concise way of doing it. It just means that whenever we get the property, we invoke this expression, and the value of that expression is what the property value is. So this expression is calling a method on mDataStore. So this is a field that we've defined here on line 11. So we have a field, which is just like a variable that is a part of belongs to this to each instance of main window. So each instance of the main window class will have this little variable that is part of that object. The variable has type DataStore, which I will show you in a minute. And when that class is created, when an instance of the class is created, we initialize the DataStore variable by creating a new object. Instantiating an object of type DataStore. Okay, so then when we're getting the orders, we then refer to that field, and we call a method on that object called getShippedOrders. So let's take a look. So I have another source file here that I call datastore.cs, and this is where I have defined the DataStore class. So so here, before I go into, so here is the getShippedOrders method on the class. You can see that it is a public method that returns a list of shipped order objects, and it's called getShippedOrders, and then below I'll show you all the rest of that in a minute. Here is the actual definition of the shipped order object itself. By the way, this is all in this query demo namespace, just like all the other code in this program. So the shipped order class has a constructor that takes these parameters, an order ID, which is integer, the shipped date, which is a datetime object, and the customer name, and we just simply set the corresponding properties. Each of these properties is defined as a read-only property, so they're all public. Order ID is an integer, ship date is a datetime, customer name is a string. Each of these properties has a getter, and we're just using this simple syntax inside the curly braces. We have get semicolon. That means that this is a read-only property. It has a getter. This gettering a property is different than a field in that getting a property means you're actually invoking code defined by the class that gives you back that value. But when we use this simple syntax of get semicolon, that code is generated for you by the compiler. There's sort of a hidden field under the hood that is storing the property value, and the getter simply returns the value of that hidden field. Now, because it's a read-only property, it can only be set in one place, which is in the constructor. So in the constructor, we can set these properties. After that, you can only get them. So this whole class is immutable, meaning you cannot change its values after it's created. Okay, so that is the shipped order class. Remember, each item in our order list was instantiated using that XAML template from an instance of the shipped order class. So these are the properties that got data bound to the text blocks in that template. Okay, so here is the actual DataStore class, and so this uses so first of all, this class is accessing an access database, which is the same database that I showed in my previous video about accessing databases from PowerShell. And I simply hard-coded the file path because this is just kind of for demo purposes. Then we have a connection object, which we're going to create in the constructor. This is of type ADODB.connection. So this is using ADODB, which is Active Data Objects Database. In order to, so that namespace is visible here. So namespace ADODB. That namespace is only available if you have to actually install a package that defines, it's like a library that you can include in your project that defines the functionality that we're using to query the database, and that functionality is in this namespace. To install that package, we use something called NuGet, and in order to do that, you can right-click on the project name in Solution Explorer. So I'm right-clicking now. Whoops, and I'm saying manage NuGet packages. And now I can see, so NuGet packages are can be published to a feed, and there is a public feed called nuget.org. And so you can search for packages that you might want to install. So I can search, for example, for ADODB, and it will show the available NuGet packages. And so, you select a package, and then you can choose to install it. Now in this case, it's already installed, so if I go from the Browse tab to the Installed tab, I can see all the packages that are installed for this project. Actually, if I clear that filter, I can see that I actually have quite a few packages installed in this project. Some of these packages were, this one I think I'm actually not using. Previously tried doing that, so I'll remove that. So, so the other projects are, okay. So the Windows App SDK here, for example, this was added by the template. When we created the project, it automatically added this NuGet package for us. This is what's pulling in the Windows App SDK stuff for us. And I think this was also added by the template. But I had to add the ADODB explicitly because I wanted to be able to query this database. Okay, so that's a prerequisite for being able to write this code that I'm about to show you. Okay, so I need to do that. All right. Not sure how I got in there. Okay, so here's our code. I'm going to build this again just to make sure that I didn't break anything by removing that package that I removed. Okay, so ADODB defines this connection class. So in the constructor for the data store object, so when we new a data store, this magic method called a constructor will be automatically invoked to initialize the object, and that is where we new the connection, and then we open the connection. And when we open the connection, we pass a connection string that specifies the name of the data provider, and then it specifies the data source, which is simply the name of the access file in this case. So this is the exact same connection string that I used in the PowerShell script. So this is really just the C# equivalent to what I already showed in the PowerShell video. So, by the way, one other thing I ran into that might bite you if you try to follow along here was that this provider is only available as a 64-bit provider. There's no 32-bit version of it. So if you build a 32-bit version of this application, then you'll get a runtime error because the provider is not found. But if you build a 64-bit version of the application, then it works. Okay, so anyway, then we have our get shipped orders method. So this is going to return a list of shipped order. A list is just is like an array, but it's a collection that can grow over time. It's not fixed in size at the time you create it. This syntax where we have list and then the angle brackets means that list is a template, or it's a generic type. And so you can have a list of integers, you can have a list of strings, or you can have a list of any type you want. And a list of shipped order cannot contain integers; it can only contain shipped orders. So it's type safe in that way. Okay, so we start by creating our empty list, and then we create a record set, and this is also part of that same namespace. So if I hover over that, we have the type is actually ADODB.recordset, so it's in the ADODB namespace. We create the record set, then we open the record set and we pass the SQL query that we want to perform. And we also then pass the connection object that we created in the constructor. And then there are these other two parameters, which are actually exactly the same as we used in the PowerShell script. But in this case, we have enums for them. So static is 3 and lock optimistic is 3. These are just the policies for how we want to. So static means that we're going to get back the data, like a snapshot of the data, and it's not going to change out from under us. And lock optimistic is just the approach we're taking to locking records as we access the database. So this is the actual SQL query we're performing. And I'm not going to go into details here because I already described this in detail in my previous video. But essentially, we're joining two tables, the customers and the orders tables, because there are some fields we want from each of them. And the three fields that we're interested in are the order ID, the shipped date, excuse me, and the customer name. So as we iterate over that record set, order ID will be field 0, shipped date will be field 1, and customer name will be field 2. So we iterate over the record set in exactly the same way we did in the PowerShell code. We call move. We have a for loop. Before entering the loop for the first time, we call move first. That's this expression before the first semicolon. Before each iteration of the loop, we test whether we're at the end of the sequence. So if the EOF property is true, we'll fall out of the loop. If the EOF property is not true, so the bang is not, if it's not true, then we will go ahead and execute another iteration of the loop. Then we execute an iteration of the loop, and then after each iteration, we call move next to advance to the next record. So we start by advancing to the first record. Then for each iteration, we check whether we still have a record. And then after each iteration, we advance to the next record. In the body of the loop, we get the three fields that we're interested in. So the record set now is positioned on whatever the current record is. Its field 0 dot value property is going to be some object. Now it just has type object because the actual data type is going to depend on the schema of the database, right? The actual type of the field. Now I happen to know because of this particular database, the order ID field is an integer, so I can cast that value to an integer using the cast syntax here, and that the shipped date is a date time object. So the date time in the datetime type in the database gets converted by the IdeoDB to a .NET datetime object, and then the third field, which is the customer name, is a string. So we do the casting here, and then these three values get passed as the parameters to the shipped order constructor, which is up here. So again, we have the order ID, the ship date, and customer ID, which are then used to initialize the three properties. So after we've constructed that object, we add it. So we knew the shipped order object. This whole expression will create this new object. That gets passed to orders.add, which simply appends that object to the orders list we created on line 35. And then we do that repeatedly until we run out of records, and then record set EOF will be true. So not records EOF will be false, and so we'll fall out of the loop. At that point, we close the record set, and then we return the list of orders we created. So that is our database query. We return the list of shipped orders, and that is how our list of records gets created that we see when we run the program, which again, I'll do right now. So when our query returned these two objects, and then the data binding caused each of those objects to be created as a list item by instantiating the template that we saw earlier. Okay, we haven't done anything yet about pane 2, so maybe that's a good thing to look at next. All right, so here's the revised program with the pane. I've replaced the placeholder text block that I had for pane 2 with another list view control. And to see how it works, let's click on the first item, and we see that just as we saw in our PowerShell script, we have one line item for this particular order. And if we click on the other order, we have 3 line items. syrup, clam chowder, and dried plums. Those are the products. The second column is the quantities. The third column is the unit price. And the last column is the product of those two. So this is what we're trying to get. And we do that by having another list view. So let's take a look at the code that achieves that effect. So here's our list view control for pane 2. We give it a name. And again, we have an item source, which is another binding expression, but this one's a little bit more complicated. And the reason it's more complicated is because of what we're binding to. Instead of binding to just a property of our class, we're actually binding to the currently selected item of the other list view. So we have the left-hand list view is called order list view. If we scroll up there, we see that, kind of collapse it down here. The left-hand list view has the name order list view on line 10. So we can refer to that here. And it has a property, the list view class has a property called selected item, which is whatever the item is that you've currently selected in the list. And when I say selected item, it actually is the actual data type of it's actually the object that is bound to that item. It's not the controls or anything like that. So in this case, that selected item is going to be a shipped order object, right? So then what I've done is I've added a items property to the shipped order object that's going to return the individual line items for that order. So to refer to that, I want to say selected item.items, but in order to do so, I actually need to specify, I have to do what amounts to a cast. So I put in parentheses that the type of this thing is local : shipped order, and that I'm getting the items property from that shipped order. And then there's one final thing. So this whole thing right here is what's called the path of the property that we're getting. And then on the right-hand side here, we have another field. So there's a comma, and then another property of this binding expression is the binding mode. Now, the default binding mode is called one time. So for compiled bindings, for xbind bindings, the default mode is one time. And that means that the binding expression is evaluated once to initialize the control, and then we're done. It never changes. One way, there are two other binding modes. There's one way and two way. So one way is a bit more complicated than one time because it means that the control is going to listen for events to see whether the property that it is bound to is changing. And if the property changes, the control will then get the new value and repopulate itself or reinitialize itself. So that's one way. Two way actually is the same thing, but in both directions. It means that changes you make to the control will actually set the properties it's bound to. So this is another way that, in effect, is kind of the controller side of the model view controller scheme. But here we only need one way because this application is only displaying data; it's not modifying data. But we do need one way if we only have a one-time binding. Pardon me. Then when we change the selected item by selecting a different item in the list, by selecting a different order rather, then the right-hand view will not update. So that's why we need the one-way binding. Now the selected item property is it supports this kind of functionality of being notified of the property changes. So we don't have to write any special code for this to work. If we had our own property that we were binding to and we wanted to use a one-way binding, we'd have to implement some sort of notification to allow the one-way binding to work. Okay, so that's the binding. Let's take a look at the data model that supports this now. So like I said, I've added a items property to the shipped order class. So let's take a look at our data store class again here. Here's our shipped order class. So to make this work, so part of this is the same as before. We have a constructor that initializes these three properties, but now it also stores a member variable of type store. So each shipped order object now holds a reference to the data store class. So we pass that to the constructor, and we initialize this field. So there is a field that is the data store object. Then we have a list of items. This is the individual order items, which are the line items associated with the particular order. And that list, we're going to initialize that lazily. So it's initially going to be null, but we will construct that list the first time we access the items property. Oops, sorry, just kind of scrolled crazily. So we have our three read-only properties that we already saw before, and then we have one new property. Now the previous properties, we just said get semicolon because we're essentially letting the compiler write the code for these properties for us. You know, they're trivial getters. But this property, we actually want to do something special. What we do is that the first time we access this property, mItems is going to be null. That's this field that we added up on line 10. So the first time we access the property, mItems is null. So when that happens, we will invoke the getOrderItems method on the store object. It will pass the order ID, which is the order ID property of this object, and it will give us back the individual line items, the order details for that order, which is a list of order items, and it will assign that to our mItems property. So we are this is a technique called lazy initialization. So it means maybe the user will never actually click on that order, so we don't need to go ahead and create this list of items up front as soon as we create the order object. But the first time the user clicks on the object, our getter, the items property getter, will be invoked, and so we will then get the items, initialize the mItems member, and that's what we return when the property is that's what the property getter returns. Next time the property getter is invoked, we'll already have our items, and so we just return the items we already received. Now we wouldn't have to do it this way. We could just do the query every time. So that's the other way we could do this. Okay, so the order item class is relatively simple. This is, again, one individual line item in an order. We have a constructor that takes the three fields that we care about, the quantity, the unit price, and the product name, and we simply set these three properties. The properties are, again, read-only properties with just trivial getters, so they just have get semicolon. The compiler will define the getter for us. Users of this class can only get these properties. They can't set the properties, so they're read-only. They can only be set in the constructor, so they can be initialized, but after that they cannot be set again. We do have one additional property. So this is the cost property because we data bind to the cost. We want to show that rightmost column is the cost. And the cost we simply define to be the quantity times the unit price. So we've seen we have multiple types of syntax in C# for creating properties. We can use the trivial getter where we have get semicolon. We can use this more complicated getter where we actually provide code. And then we can use some sort of in between these two. We have a getter where we write code, but it's just a single expression. And in that case, we can use this, what's called a lambda syntax. So we use this equal sign, right angle bracket, and then we have the expression that gets evaluated, and the value of that expression is what the property getter returns. And then back to our data store class. So the first stuff is all the same. Here's our getShippedOrders method that we looked at before. It's exactly the same, except now when we invoke the shipped order constructor, we have to pass this parameter because the shipped order constructor now takes a data store object as its first parameter. But otherwise, that method is the same. Now here is our new method to get the order items. So we take the order ID as a parameter. So we're getting just the items that are associated with that order ID. And in the database, basically we have one big table of order details that has all the items for all the orders. But one of the columns in that table is the order ID. So if we query for that, we get just the line items that correspond to the particular order we're interested in. So here is so again, we create the list that's going to be our return value, an empty list of order items. We create a record set. We open the record set passing the SQL query. Again, this is a query that I explained in the PowerShell video, so I'm not going to repeat myself. But it returns, it joins two different tables, and it gets the quantity, the unit price, and the product name. So those are the three particular values we're selecting. And so field 0 will be the quantity, field 1 will be the unit price, and field 2 will be the product name. Otherwise, this is the same as the previous function. Again, we have a loop that works exactly the same way as before. And then within the body of the loop, so for each record that we get back, we're going to create an order item. We're going to pass those three values as the parameters to that constructor. And add that to the list. And again, we have to, the value property of each field is just an object. So the static type, if you will, is just object. It doesn't know, we don't know at compile time what the actual type of the object is going to be, but we can use a cast to convert to basically say, okay, I know that this object is actually an int16, even though at compile time, even though the compiler just knows that it's an object. And that's based again on knowing what these fields actually are in the database. Now it's interesting, the quantity is not an int, it's an int16. If you actually specify the wrong type here, you'll get a runtime error because there is a runtime check to see whether the actual type of the object matches the type you're casting to. So the three values we're getting are an int16, a decimal, and a string. And incidentally, in the PowerShell script, I used floating point, or I used a double, I think, for the monetary values. Decimal is actually a more appropriate type for this, so I probably should have used decimal in PowerShell as well. Okay, anyway, once we've iterated over all the records in the record set and created the order item objects for them, we close the record set and return the orders. So once again, so the shipped order class now has an items property that when we get that property for the first time, we'll call this new method on the data store to get the order items, and then that value will be cached on the data store and cached on the shipped order object and then returned as the value of this property. Whew, okay, so that is our database. That is our sort of data model, extending our data model to have the line items, the order details. Let's go look now at the XAML markup that takes advantage of this. And again, we saw our binding expression for the items source. We got the selected item from the other list, from the left-hand list, and then that selected item is expected to be a shipped order object, and so we get its items property, which is this list of order items. So now if we expand out to see what the item template looks like, this is how each of those order item objects is going to then be instantiated to give us a list item. We again have a grid, and in this case we just have a grid with a bunch of columns. So we have a column that's going to be the product name. We have a column that's just for spacing. We have another column that's going to be the quantity. Another column that's just for spacing. Another column that's going to be the unit price. Another column that's just for spacing. Another column that's going to be the cost. So here's again, we're using, so we have a text block that is data bound to the product name. Again, this is getting the product name property from the order item object. Again, the type of order item being specified as the data type of the template. So we're going to get the product name from the order item, and that's data bound to the first text block, which is in the column 0. Then column 2, we have the quantity property is data bound to the text of the text block. Column 4, the unit price property is data bound to the text block, and column 6, the cost property. And again, when we run this program, we see that that grid that we show right there is what we see in the right-hand list. So every time we click a different item in the left-hand list, its selected item changes, which is what we see on line 51, and that causes this one-way binding to be reevaluated. And then when that reevaluation occurs, that it instantiates this template, this data template, for each order item, and the columns have the values that are bound to the properties that we saw in that order item class. Okay, so that completes our demonstration of how to use data binding with WinUI 3 in C# and XAML to create a graphical version of the to create a graphical presentation for the queries that we showed in that previous PowerShell video. Thank you for watching, and I hope that this was interesting for you. Thanks. Bye.